Day 132, Honors Physics, Electrostatics, Electric Forces, problem number 40. So now that we've done a couple of electric field problems, this is now back to Coulomb's law and force problem. For example, you have the scenario as we have laid out here, 3-point charges at the vertices of this triangle, and we're looking for the net force and the direction, this magnitude and direction of the force on this charge right here. So these two charges, the 20 and the negative 40, attract each other, and we can calculate that by Coulomb's law right here. F equals kqq over the distance squared, which is 30 centimeters. And I'm looking at F2, but F1 would be the same magnitude, but we don't really care. I drew F sub 1 because they come in pairs, but I really don't care about F sub 2. And I do the same thing over here for the negative 40 and the 80. Once again, when I plug in, I don't plug in the negative 40. The negative has been taken care of with these directional arrows. That's all the negative is good for, is telling you whether they attract or repel. Since this is a negative 40 and a positive 80, they attract. Once again, I don't care about F sub 3 over here. I really care about F sub 4. Now, F sub 4 will not be the same as F sub 2. So you calculate F sub 2 and F sub 4, and then you have to combine those two vectors to get your vector resultant. And it's pretty easy to get the magnitude of the final answer for part A here. And that's really all you have to do is part A. You don't have to do part B here. So this is part A. But bottom line is you Pythagorize it to get the magnitude of the resulting vector. And the resulting vector will be somewhat in this direction, up and to the right, pointing this way. Well, it would be about, I would draw it from here, from the spot here, from this spot right here, up into this right here. If I drew my vector box, it would point to that spot that I have labeled right there. And you could figure out the angle using either sine, well, probably tangent of an angle. Label an angle and get that direction, and you're good to go.